Okay, this is the review for our Unit 11 test. This is on page 25 in your packet. So this is our section where we're talking about quadratics and factoring and how to solve quadratics. So this first section tells us to factor, and we're going to factor by factoring out the GCF. So first thing you look at is the coefficients. What's the greatest number that can divide into 8 and divide into 12 evenly? And it's a 4. And then you look to see if they both have x's. And they do. What's the greatest number of x's they both have? Well, they both have 1. This one has 2. This one has 1. So the greatest number of x's they both have is 1. So 4x is our GCF. Every time we have a GCF, we build only one set of parentheses back behind it, and then we have to figure out what goes in the parentheses. So 4x times what would give me 8x squared? 2x. And 4x times what would give me a negative 12x? A negative 3. And then we will, later on, see if we can factor what's in the parentheses. But this I can't do anything with because there's no GCF, nor is it a difference of squares. So this is our answer. Okay, number 2. I start by looking at the lead coefficients. What's the biggest number that can divide into a 5 and divide into a 10 evenly? 5. And what's the greatest number of D's they both have? They both have 1 D. So 5D is my GCF, and then I'm going to build my one set of parentheses back behind it. And then I ask myself, 5D times what will give me this back? So 5D times what gives me 5D cubed, D squared, and 5D times what will give me 10D? And it's a positive 2. And then I look to see if I could do anything with that, and I can't because it doesn't have a GCF, nor is it a difference of squares. So we're done with this problem. Okay. This one, I look at the 6, the 12, and the 24, and I ask myself, what's the greatest thing that can divide into 6, divide into 12, and divide into 24 evenly? And the greatest number that can go into all three of those is 6. Now, do they all have m's? Yep. What's the greatest number of m's they all have? They all have 1. They don't all have 2, and they don't all have 3, but they all have 1. So that's our GCF. Then we build our one set of parentheses back behind it. So 6m times what gives all of it back? So 6m times what makes 6m cubed, m squared. 6m times what makes a negative 12m squared, a negative 2m. And 6m times what makes a negative 24m, a negative 4. And then I'm just going to see if I can do anything with this back here. There is no GCF, but if I try to factor it with my a times my c, my a is a 1, so if I try to do a times c rooftop, 1 times negative 4 makes negative 4, and I'm looking for things that add to be negative 2. So anything that multiplies to be negative 4, that adds to be negative 2. And there's nothing. So this is it. Okay, number 4. What do you think the GCF is? Well, the greatest thing that divides into 2 and 4 evenly is a 2. Do they both have an x? Nope. Since they don't both have an x, we can't pull any x's out this time. I build my one set of parentheses. 2 times what makes 2? 1. And 2 times what makes negative 4x? A negative 2x. And then this is nothing in the parentheses. No GCF, no difference of squares, so there it is. So that's a little practice factoring out the GCF. Okay. A difference of squares. Remember, the word difference means there has to be a minus sign in the problem. If you don't see a minus sign, there's no way it can be a difference of squares. So number 5, it does have a minus sign. These are both perfect squares surrounding the minus sign. So I slap down my two sets of parentheses. One gets a plus, one gets a minus. And then I write down the square roots. What's the square root of x squared? X. And what's the square root of 9? 3. And that's your answer. Okay, number 6. I look to see if I have a minus, and I do, and then I look to see if those are both perfect squares surrounding the minus, and they are. So I slap down my 2 sets of parentheses. One gets a plus, one gets a minus, and then I write down the square roots. What's the square root of 4m squared? 2m. And what's the square root of 1? 1. Most students love to do difference of square problems, so hopefully these are easy. Okay, number 7. I look to see if I have a minus. I do. Then I look to see if those are both perfect squares. They are. So I slap down my 2 sets of parentheses. One gets the plus, one gets the minus. Then I write down the square roots. What's the square root of 16c squared? 4c, so that goes in the front. And then what's the square root of 49d squared? 7d, and that goes in the back. Okay, this next section, it asks us to factor each expression completely, and it says they'll either be a GCF, a difference of squares, rooftop, or maybe a combo of all the different things that we've talked about so far. So, first thing I always look for, no matter what, is there a GCF? That's your first rule of factoring. So number 8, is there anything that will divide into 14 and into 8 evenly? And what's the greatest thing? 2. Now, do they both have y's? Nope. So I build my 1 set of parentheses back behind it, and then 2 times what gives it back. So 2 times what makes 14y, 7y. 2 times what makes negative 8, negative 4. And then I cover my GCF up. I try it again. Does this in here have a GCF? No. And then because it's 2 terms, I look to see if it's a difference of squares. It is a difference. 4 is a perfect square, but 7y is not a perfect square. Y doesn't have an even exponent, so that's a problem, and 7 is not a perfect square. So we're done at that step right there. Okay, number 9. First thing I look to see is, do I have a GCF? Nothing goes into 124 and 144 besides the 1. And then they don't all have x's, and they don't all have y's. Okay, so no GCF. And then it's got 1, 2, 3 terms, so I'm going to do rooftop. So my a is a 1. So what's a times c? 144. I want them to add to be the 24 in the middle. So what 2 numbers multiply to be 144 that add to be 24? 12 and 12. Okay, because of the 1 in front, I can shortcut. So I'm going to build my 2 sets of parentheses. Now to get x squared, x goes here and here, and then I just write those numbers down. So that's a positive 12, so I write plus 12. That's a positive 12, so I write plus 12. The only hitch about this problem that you might not have noticed is this y squared back here. So this times this has to make the 144y squared. So 12 times 12 makes the 144. What times what would make the y squared? Y times y. And there's our answer. Okay, number 10. First I look to see, do I have a GCF? Nothing goes into 10, 11, and 3 besides a 1. So no. Then I look to see how many terms? 1, 2, 3. So I'm going to do rooftop. So I take my a times my c. So what's a times c? 30. I want them to add to be the little guy in the middle, the 11. So what 2 numbers multiply to be 30 that also add to be 11? What 2 numbers do that? 6 and 5. Okay, can I shortcut? I cannot. Since it's not a 1 in front, I can't shortcut. So I recopy the very first term, and then instead of using the middle term, I use these numbers over here. So that's a positive 6, so I write plus 6. Just don't forget to put the x behind it. That's a positive 5, so I write plus 5. Don't forget to put the x behind it. And then you drop the plus 3. So for anybody that's been confused, the first term just drops. The back term just drops. Instead of using the middle term, we use the 2 numbers we came up with, and that's because 6x plus 5x is the same thing as 11x, so mathematically you can replace it. Okay, at this point I start looking for the GCF out of the front and the GCF out of the back. So out of the front 2, what's my GCF? The greatest thing that goes into 6 and 10 is 2. The greatest number of x's they both have is 1. I build my 1 set of parentheses. 2x times what is 10x squared? 5x. 2x times what is 6x? 3. Okay, in the back, what's your GCF out of that? Nothing goes into 5 and 3 besides a 1. So we're going to write the 1 down. They don't both have x's, so you can't put any x's down. So I build my one set of parentheses. This is where I like to cheat. Whatever I write here, I write here. And then in order for this to distribute to give you what you see up here, this needs to be a positive 1. So positive 1 times 5x makes that positive 5x. Positive 1 times 3 makes positive 3. Okay, so I take what's in both of these parentheses, I write it one time. Then I take what's left over, 2x plus 1, and I write it in its own set of parentheses. And then that's it. I'm done. Now we are just factoring here, we're not solving. We've talked about solving, that's where I set these equal to 0 and keep going, but this is just factoring. Okay, next one. I look to see if I have a GCF. Does anything go into 1, 8, and 48 besides a 1? Nope. Do they all have y's? Nope. 2 terms or 3? 1, 2, 3. So I'm going to go a times c rooftop. So a times c is negative 48. I want them to add to be the guy in the middle, the negative 8. So what two numbers will multiply to be negative 48 that add to be negative 8? What two numbers? Negative 12 and positive 4. Can I shortcut? I sure can. It's got the 1 in front, so I can shortcut straight to it. So 2 sets of parentheses. To get the y squared, y goes here and here. And then I just write those numbers down. That's a minus 12, so I write minus 12. That's a positive 4, so I write plus 4. And we're done. Okay, number 12. First I look to see if I have a GCF. Anything go into 6, 13, and 6 besides a 1? Nope. Then I look to see 2 terms or 3. It's 3 terms. So I'm going to do my a times my c rooftop. So a times c makes 36. I want the numbers to add to be negative 13. So what two numbers multiply to be 36 that add to be negative 13? Negative 9, negative 4. Can I shortcut? Unfortunately, I cannot. So I recopy the first term. Instead of using the middle term, I use both of these. So a minus 9, don't forget the x behind it. A minus 4, just don't forget the x behind it. And then I drop the plus 6. So first term, drop. Back term, drop. Middle term, use these guys. All right. Looking for the GCF out of the front and then the GCF out of the back. So what's the GCF I have out of my front? The biggest thing that goes into 6 and 9 is 3. Greatest number of x's they both have is 1. So 3x is the GCF. 3x times what is 6x squared? 2x. 3x times what is negative 3 or negative 9x? Negative 3. In the back, what's my GCF? A 2. 2 is the biggest thing that goes into 4 and 6. Then I get a cheat. Whatever I write here, I get to write here. Remember, they have to be an identical match. These have to look exactly the same. Now this has to distribute to give me this. So what kind of 2? Negative 2. Negative 2 times 2x is negative 4x. Negative 2 times negative 3 is positive 6. Okay, so 2x minus 3 goes in one set of parentheses. And then what is left over? 3x minus 2, so that goes in the other set of parentheses. And there he is. Okay, number 13. Does number 13 have a GCF? Nope. 3 terms, so here we go. A times c rooftop. What's a times c? 5. You want them to add to be the negative 6. So what two numbers multiply to be 5 and add to be negative 6? Multiply to be 5, add to be negative 6. Negative 1, negative 5. Okay, can I shortcut? I sure can. It's got the 1 in front. So build your 2 sets of parentheses. To get the w squared, w goes here and here. And then I just write my numbers down. So I write down my minus 1. I write down my minus 5. And done. Whoa. Okay, number 14. First I look to see if I have a GCF. Nothing goes into 1 and 144 besides a 1. They don't both have b's. Okay, so no GCF. Then 2 terms or 3? Two terms. So the only thing I have to look for, is it a difference of squares? It is a difference because of the minus. Are these both perfect squares? You betcha. So two sets of parentheses, one with the plus, one with the minus. Then I write down the square roots. What's the square root of b squared? B, so b goes, here and here. Almost messed that up. What's the square root of 144? 12, so 12 goes here and 12 goes here. And we're done. This factoring's not so bad. Let's stop and give a little smiley face. Okay, number 15. First thing I look for, do I have a GCF? Anything that can go into 27 and 12. Yes, we have a 3. So I build my set of parentheses. 3 times what makes 27x squared? 9x squared. 3 times what makes negative 12? Negative 4. Then I'm going to cover my GCF up and try it again. Does this in here have a GCF? No, it does not. And then does it have 2 terms or 3? 2. So I look to see if it's a difference of squares. Is it a difference? You betcha. Are those both perfect squares? Yes, they are. So slap down your 2 sets of parentheses. One gets the plus, one gets the minus. Then we lay down the square roots. What's the square root of 9x squared? 3x, so that goes here and here. What's the square root of 4? 2, so 2 goes there and there. Mr. GCF, don't forget to drop him. Okay, on to number 16. First thing we want to look for, do we have a GCF? Yes, we do. The biggest thing that goes into 3, 18, and 24 is a 3. Do they all have y's? Nope. So 3 is the GCF. So 3 times what gives all that back? 3 times what makes 3y squared? Y squared. 3 times what makes 18y? 6y. 3 times what makes 24? 8. Then we cover up Mr. GCF. We try it all again. This in here, does this have a GCF? No, it does not. And then I look to see 2 terms or 3? 3 terms. So we're going to go a times c rooftop. So a times c makes 8. We want the numbers to add to be 6. So what 2 numbers multiply to be 8 that add to be 6? 2 and 4. Can I shortcut? Yes, I can. It's got a 1 in front. So I build my 2 sets of parentheses. To get y squared, y goes here and here, and I write them down. That's a plus 2, so plus 2. That's a plus 4, so plus 4. And Mr. GCF, don't forget to drop him. So this is what you would call a combo, where we have more than one thing happening. Okay, 17. I look to see if I have a GCF. Anything divide into 25 and 64? Nothing besides a 1. Do they both have k's? Nope. So 2 terms or 3? 2. So I look to see if it's a difference of squares. And it is! So 2 sets of parentheses. One gets the plus, one gets the minus. What's the square root of 25k squared? 5k. And what's the square root of 64? 8. And I'm going to stop the video here, and we'll do more of this review later. Thank you!